Hi and welcome to Politics Tech Lightning. This is the video you want to watch in order to pass the Azure Fundamental AZ-900 in the fastest possible way. In less than 2 hours, you will get all the information necessary to pass this exam with flying colors. How is this possible, you may ask? Well, I'm using a variety of sources such as digital whiteboards, face cams, screenshots and other recordings to make sure that you retain the information easily. In addition to the video, the entire course is published in PDF format and freely available to download. Check out the links in the description of the video for this download. Keep in mind that this exam is very theoretical, so understanding the terminology, concept, and what they do is enough to pass. I am following the official Microsoft curriculum. There are 11 sections in total that we will cover, and there's an overview of all the different chapters in the video description, so you can then and immediately easily jump to the section that you need. Having the introduction out of the way, let's now get started with our first section. Here we go. We're going to describe the cloud concepts, which accounts for 20 to 25% of the exams. We will identify the benefits and consideration of using the cloud services. So, if we look at the benefits and the cloud computing, such as high availability, scalability, elasticity, agility, and disaster recovery, we can say that Microsoft, they have invested a lot of money into making a cloud infrastructure that's scalable and modular. So in a well-architected framework and solution, enterprise companies can take advantage of all these investments that Microsoft have made. To fully grasp the concept, we first have to understand a little bit about Azure. A region in Azure, for example, West Europe, is located in Amsterdam. Within this region itself, there are 3 availability zones. These are comparable to data center. This is only one region. So imagine you have many regions all over the world with capability to have services in each one of them. High availability means that you can spin up multiple virtual machines or other Azure services in one availability zone, data center, and even span them between different availability zones and across regions. The same applies to scalability. Imagine you have a web shop selling popular merchandise. Now, since this video is about Azure, I will not mention Amazon as an example for this. Certain parts of the year, such as Christmas or Valentine's Day, there may be a huge increase in visitors. The cloud allows you to easily scale up your workload with thousands of machines and resources to meet demand. Automatic scaling up and down this way is referred to as elasticity within Azure. Agility is within the same context. Your organization can very quickly build and manage and deploy applications on a global scale. Of course, disaster recovery ties into this, where you can use the same feature, such as Azure Site Recovery, to fail over workload from one site to another. We're going to identify the differences between capital expenditure, such as CAPEX, and operational expenditure, OPEX. Now, there are 2 ways for a business to invest. We have capital expenditure, CAPEX, which is an investment in the form of assets that return back investments over time. This can be, for example, a purchase of a server, which will provide a ROI, return of investment, in a foreseeable future. Then we have an operating expense, OPEX, which is actually an expense required for the day-to-day functioning of the business. In the IT field, this is related to all the running costs of keeping a server available. So this is in stark contrast as how you pay for resources in the cloud. And that's where the consumption-based model comes into play. It's actually the pillar of the cloud, where you only pay exactly for what you consume. So in Azure, you actually only pay for the resources that you're using, may it be CPU, storage, or any other Azure components. Section 2, we're going to describe the differences between the categories of the different cloud services, and we're going to have a look at the shared responsibility model. Exciting stuff. So The shared responsibility model, that's actually there to divide up the responsibilities of the infrastructure, right? So in an on-premise data center, you own and are responsible for the whole stack. As you move to the cloud, some of these responsibilities, they transfer to the cloud provider. Now, there are different layers, just like an onion, and responsibility models for this. We have infrastructure as a service, IaaS. This is, for example, virtual machines running in the Azure cloud. Microsoft, they provide the underlying infrastructure to manage and support this virtual machine, the hypervisor. You only need to be responsible for the virtual machine itself. There's no need to worry about this underlying hypervisor itself. Then we have Platform as a Service, PaaS. This is where Microsoft, they're responsible not only for the underlying infrastructure, but for the platform itself. A good example that we all know about are the databases in Azure. You can have SQL as PaaS service, meaning you don't need to worry about the installation nor patching of the database software. Then we have Software as a Service, SaaS. That's where Microsoft provides access and end-to-end availability of the full application. Good examples of this are Hotmail by Microsoft, Gmail by Google, where you just configure and plug in your client. The running configuration and maintenance of the software is all done by the provider. Then we have something that's called serverless computing. Imagine you have a Java application, and this one performs certain business functions. Instead of hosting or renting a full server to run this application, you can use serverless computing. It means that you get a ready-made environment, well, in this case, a Java environment, where you can run your application. You don't need to configure anything on the OS level or install any interpreters. Then we come to section 3, where we're going to describe the differences between the types of cloud computing. So let us first define cloud computing. We say that cloud computing, it's on-demand availability of computing services, including servers, storage, databases, networking, software, and analytics. Now, you typically only pay for the cloud services that you use. That means that you help lower your operating costs. You run your infrastructure more efficient and scale up and down as your business needs change. You have 3 types of clouds. We have the public cloud, private cloud, and the hybrid cloud. The public cloud, now that's where computing resources are available for anyone to purchase. Examples of public clouds are, of course, Microsoft Azure, Amazon Web Services, AWS, and Google Cloud Platform, GCP. The public cloud provider leverages their resources and infrastructure for multiple customers. A private cloud, now that's a model of computing resources which are dedicated to one organization. If you are a large enterprise, you could have a provider set up a complete private cloud. Now this cloud would be used only for your organization, right? So you wouldn't be sharing any of the underlying infrastructure or any of the components with anyone. Then we have the hybrid cloud. Now, hybrid cloud, it's in the middle where you have the best of both worlds. You may have your own private cloud for certain applications and business critical information. For other workloads, you integrate or purchase some services by a public cloud provider. And then you can integrate these services into the hybrid cloud. Now we're at section 4. We're going to look closer at the architectural components. Microsoft have their Azure infrastructure divided up into regions, like we mentioned. A regions within Azure is defined as data centers deployed within a latency-defined parameter. Example of regions are West Europe. This is located in Amsterdam. We have North Europe. This is in Ireland. Central US, East US, and many, many more regions all over the world. Now, Microsoft, they continuously invest and expand these regions into new territory, so there will be a lot of updates coming to these. Now, that brings us into something called regional pairs. For example, West Europe, Amsterdam, its regional pair is in North Europe, Ireland. Now, there are options to, for example, easily provide redundancy for certain cloud services across regions. Now, if you have an Azure storage account in the West Europe and you enable cross-region replication, it will automatically be replicated to the regional pair North Europe in Ireland. So let's have a look at the availability zones. Availability zones, that's a term used in Azure, and you can think of it as data centers. Now, within a region, you have different availability zones, data centers. Usually, there are 3 availability zones in each region. For some Azure services, you can actually specify which availability zones they should be located in. This provides for some redundancy within the actual region itself. Now we're going to have a look at the benefits and usage of resource groups. And if we look at resource groups in Azure, now they're just a logical construct, right? Resource groups are created using the Azure Portal. You can also use other interfaces, and there's no cost associated with them. They're a powerful way to logically arrange resources. You can, for example, put all resources related to one application into one resource group. You can think of it as a folder where you put in file, but in Azure, instead of files, it's resources you put into them. So, having a look at resource group, we're moving on to subscriptions. In Azure, you have to create a subscription in order to put resources in. Subscription, they serve as both a financial and a management boundary. So it's common practice actually to have multiple subscriptions for an organization. It really depends on your billing and management requirements. There is no extra cost by Microsoft to create additional subscriptions. You only pay for the actual infrastructure that you create in these subscriptions. With that out of the way, we're going to talk briefly about management groups. Now, management groups, they provide a level of scope. If you have the subscriptions here, management groups are above the subscriptions. You can put policies and rights on these management groups. And policies in Azure can be, for example, you want to limit the deployment of virtual machines only to a specific region. You can set this policy, you can apply it to a management group, and have this then to apply to all the subscriptions underneath that one management group. And then we're going to have a look at Azure Resource Manager. Now, Azure Resource Manager is the deployment and management service for Azure. It provides a management layer that enables you to create, update, and delete resources in your Azure subscription. Whenever you interact with Azure, you call the Azure Resource Manager. This can be done using the Azure Portal, Azure CLI, PowerShell, or by using REST clients. Then we have the ARM templates, which is a way to deploy resources in Azure. It's just a JSON template filled with parameter on which resource and how to set it up. There are several benefits of using the Azure Resource Manager. Some of them is that you can easily deploy, manage, and monitor all the resources as a group rather than individually. As mentioned, you can use PowerShell to perform changes on multiple resources. Then you can redeploy your solution and be confident that everything is deployed in a consistent state using templates. You can easily apply RBAC access control. You can do that on all services as it's natively integrated in Azure. And resources that you create already have this RBAC control system available and ready to use for them. And we're going to have a look at Azure resources. Now, it's very simple. An Azure resource is just anything that is deployed in Azure. May it be a storage account, IP address, or anything which you can deploy. When you, for example, deploy a virtual machine, you're not only getting one resource in Azure. So it's not only one virtual machine, but you get a resource for each component of that virtual machine, such as a storage account, networking, IP address, and VM itself. We're at section 5. We're going to describe the core resources available in Azure. So we're looking at the benefits of virtual machines, Azure App Services, Azure Container Instances, ACI, Azure Kubernetes Services, AKS, and Azure Virtual Desktop. Now, let's start with the virtual machine. Some of the benefits there. The strength of Azure with virtual machines is the scalability. You can leverage all the Microsoft infrastructure to quickly scale up and down your virtual machines. If your business has a peak usage at a certain time frame, you can scale up. After the peak, You scale down and your build will reflect this. Then we have Azure App Services and the benefits thereof. Azure App Service, it's an HTTP-based service for hosting web application, REST APIs, and mobile backends. Some of the benefits are you can have multiple languages and framework that the app services support. It has support for ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, and Python. You can use the global scale with high availability, scale up or out manually or automatically. You can host your apps anywhere in the global Microsoft data center infrastructure. You're also security and compliance with the app service, SOC and PCI compliant built in. Restless code, you run a code snippet or service on demand without having to explicitly provide or manage the infrastructure. And you only pay for the compute time your code actually use. We have Azure Container Instances, ACI. Those are becoming the preferred way to package, deploy, and manage cloud applications. Azure Container Instances, they offer the fastest and simplest way to run container in Azure without having to manage any virtual machines and without having to adapt a higher level service. Some benefits that the containers offer are significant startup benefits over virtual machines, VMs. Azure Container Instances, they can start containers in Azure in seconds without the need to provision and manage VMs. Azure Container Instances, they also enable exposing your container groups directly to the internet with an IP address and a fully qualified domain name, FQDN. It provides optimum utilization by allowing exact specification of CPU, cores, and memory. You pay based on what you need and get billed by the second. So you can fine-tune and spread your usage based on the actual need. Then we have Azure Kubernetes Services, AKS. Now, AKS, it simplifies the deployment of a managed Kubernetes cluster in Azure. It does this by offloading the operational overhead to Azure itself. As a host of Kubernetes services, Azure handles all the critical tasks like health monitoring and maintenance. Some of the benefits of AKS are it integrates with Azure Active Directory for Kubernetes RBAC. It has integrated logging and monitoring through the use of Azure Log Analytics. And AKS, it supports the creation of GPU-enabled node pools. Also, regarding security, AKS is security compliance with SOC, ISO, PCI, DSS compliancy. Then we have Azure Virtual Desktop. Now, Azure Virtual Desktop is a desktop and app virtualization service that runs in the cloud. You can create a full desktop virtualization environment in your Azure subscription. Now, you can bring your own image for this, for production workload, or you can use them from the Azure Gallery, ready-made images. They are persistent personal desktops, meaning each user can be the owner of his virtual desktop. Once assigned, users can launch any Azure Virtual Desktop client to connect to their published Windows desktop and applications, or they can connect to them from any device, either through a native application on the device itself or Azure Virtual Desktop HTML web client. We're going to describe the benefits and usage of virtual networks, VPN gateways, virtual network peering, and ExpressRoute. Azure Virtual Network, vNet. Now that's a fundamental building block in your private network in Azure. vNet, it enables many types of Azure resources, such as Azure Virtual Machines, VMs, to securely communicate with each other. They can also communicate with the internet and on-premise networks. vNet is similar to a traditional network that you'd operate in your own data center. You can connect vNets through a process called virtual network peering. Even vNets in different subscriptions can be paired and connected together. A VPN gateway. Now that's a specific type of virtual network gateway that is used to send encrypted traffic between an Azure virtual network and an on-premise location over the public internet. You can also use a VPN gateway to send encrypted traffic between Azure virtual networks over the Microsoft network. Now, each virtual network can have only one VPN gateway. However, you can create multiple connections to the same VPN gateway. When you create multiple connections to the same VPN gateway, then all VPN tunnels, they share the available bandwidth. And then we go into ExpressRoute. So now ExpressRoute, in contrast to VPN, which uses the public internet to connect to Azure, ExpressRoute is a private connection for your enterprise. You can establish connectivity to Azure and other Microsoft 365 services with ExpressRoute. And you also have an SLA on the ExpressRoute, which is something that's not available with VPN. ExpressRoute is used by large enterprises who require a dedicated connection and SLA to Azure. Blob Storage. So Azure Blob Storage is Microsoft's object storage solution for the cloud. Now, Blob Storage, it's designed for example, serving images or documents directly to a browser, storing files for distributing access, streaming video and audio, writing to log files, storing data and backup, restore, and disaster recovery and archiving. Storing data for analysis by an on-premise or Azure-hosted service. For Blob Storage, you have 3 tiers to store data. You have hot, cold, and archive. Now, hot is the standard where you actually access the data frequently. Cold storage is suitable for data that is not accessed frequently by application and is expected to be stored for a minimum of 30 days. For example, for short-term storage of backup. Right? Then we have the archive tier. As the name indicates, this is the tier which is intended to be used to store rarely accessed data. Its storage rate is the cheapest on Azure, but the data retrieval charges are the highest. In other words, you pay to read your own data. Disk storage. Azure managed disks are block-level storage volumes that are managed by Azure and used by Azure virtual machines. Managed disks are like physical disks in an on-premise server, but in this case, they are virtualized. With managed disk, all you have to do is to specify the disk size, disk type, and you can provision the disk. Once the disk is provisioned, Azure handles all the rest. You have different types of managed disks. You have ultra disks, which are SSDs. Those are data-sensitive workload disks for SAP HANA, for example. Then you have premium SSDs, which are high-performance sensitive workload disks. You have standard SSDs or standard hard disks. These disks come in different flavors where you specify size and availability on the managed disks. Then we have file storage, which is a storage account in Azure that can be enabled for Azure Files. This means that you can enable access to the storage account like you would as a normal file server. You can move all or part of your file servers from on-premise to the cloud. Workstation can access the files using SMB 3.0 protocol. They can do this regardless where they are located, of course, provided there's connectivity to Azure. You can utilize the power of the cloud with flexibility to add more storage, and you only pay for the use. No longer are you required to buy an expensive or large disk cabinet that is enough to handle a long future growth. As Azure Storage Data Redundancy. Now, Azure Storage always stores multiple copies of your data, so it's protected from planned and unplanned events, including transient hardware failures, network or power outages, and massive natural disasters. When deciding which redundancy option is best for your scenario, consider the trade-off between lower cost and higher availability. There are 4 options to choose from in Azure when it comes to disk redundancy. You have LRS, which is locally redundant storage, ZRS, zone redundant storage. We have GRS, geo redundant storage, And we have GZRS, which is Geo-Zone Redundant Storage. LRS, now this copies your data synchronously 3 times within a single physical location in the primary region. LRS is the least expensive replication option, but it is not recommended for applications requiring high availability or durability. ZRS, now this copies your data synchronously across 3 Azure availability zones in the primary region. For applications requiring high availability, Microsoft recommends using ZRS in the primary region, but also replicating this to a secondary region. GRS, now this copies your data synchronously 3 times within a single physical location in the primary region using LRS. It then copies your data asynchronously to a single physical location in a secondary region. Within this secondary region, your data is copied synchronously 3 times using LRS. GZRS, it copies your data synchronously across 3 Azure availability zones in the primary region using ZRS. It then copies your data asynchronously to a single physical location in the secondary region. Within the secondary region, your data is then copied synchronously 3 times using LRS. Now we're going to look at the benefits and usage of Cosmos DB, Azure SQL Database, Azure Database for MySQL, Azure Database for PostgreSQL, and SQL Managed Instances. So, Azure Cosmos DB, let's start with that one. It's a fully managed NoSQL database for modern app development. It has a single-digit millisecond response time, and it has an automatic and instant scalability along with guaranteed speed at any scale. Benefits for Azure Cosmos DB, for examples, are real-time access with fast read and write latencies globally and throughput consistency, all backed up with an SLAs. There are multi-region writes and data distributions to any Azure region with just a click of a button. You can independently and elastically scale storage up and down throughout any of the Azure regions. Even during unprecedented traffic bursts, the service is available with minimum latency. Then we have Azure SQL Database, which is a managed service PaaS database engine that handles most of the database management functions, such as upgrading, patching, backups, and monitoring without the administrator's involvement. With single databases, each database is isolated from others and is portable. Each has its own guaranteed amount of compute, memory, and storage resources. The amount of the resources assigned to the database is dedicated to that database, and it's not shared with other databases in Azure. You can dynamically scale a single database resource up and down. And then we have something called elastic pools. Now, this is where you can assign resources that are shared by all databases in the pool, right? So you can create a new database or move the existing single databases into a resource pool to maximize the use of the resources that you have assigned to this pool. This way you can save money. So Azure Database for MySQL is another topic. It's also a fully managed platform as a service based on MySQL version 5.7 and 8.0. There are 2 deployment methods available for this. You have the flexible server and you have the single server. The flexible server is a fully managed production-ready database service. It has multiple high availability options. It also gives you more control over the database management and configuration settings as opposed to, for example, the single server. Now, the single server option, it is there with built-in standard configuration for patching, backups, high availability, and security. Microsoft, they actually recommend, of course, to use the flexible server as the deployment method of today. We absolutely cannot forget about Azure PostgreSQL and the Azure SQL Managed Instance. Azure PostgreSQL. So The Azure Database for PostgreSQL is a relational database service based on the PostgreSQL Community Edition. There are 3 deployment options available to you for PostgreSQL. You have single server, flexible server, and hyperscale sites. Starting with the single server, the deployment option offers 3 pricing tiers: basic, general purpose, and memory optimized. Each of these tiers offers different resource capabilities to support your database workloads. You can build your first app on a small database for a few dollars a month, and then you can adjust the scale to meet the needs of your solution. Single servers are best suited for cloud-native applications that are designed to handle automated patching without the need for any granular control on the patching schedule and any custom PostgreSQL configuration settings. Then we have the flexible service. Now, the flexible service provides more flexibility and customization based on the user requirements. The flexible server infrastructure, it allows users to opt for high availability within single availability zones and across multiple availability zones. Flexible server provides better cost optimization controls with the ability to stop and start the server, and burstable compute tier, which is ideal for workloads that do not need compute capacity continuously. Flexible server, they're best suited for example, for application developments where they require better control and customizations. Cost optimization controls with the ability to stop and start the server. Zone redundant, high availability with them. You have managed maintenance windows. Then we have the hyperscale Citus option, which horizontally scales queries across multiple machines using sharding. Its query engine parallelizes incoming SQL queries across these services for faster response on large data sets. It serves applications that require greater scale and performance, generally workloads that are approaching or already exceed 100 gigabytes of data. The hyperscale Citus deployment option delivers the following. We have, for example, horizontal scaling across multiple machines using sharding. We have query parallelization across these servers for faster response on a large data set. It's excellent for multi-tenant applications, real-time operational analytics, and high throughput transactional workloads. Azure SQL Managed Instances. Azure SQL Managed Instance is designed for customers looking to migrate a large number of apps from an on-premise or IaaS, self-built or ISV-provided environment to a fully managed platform as a service cloud environment. You have a very low migration effort between the two. SQL Managed Instance runs with all the features of the most recent version of SQL Server, including online operations, automatic plan corrections, and other enterprise performance enhancements. The purchasing model for SQL Managed Instance is vCore base. That gives you the flexibility, control, transparency, and a straightforward way to translate on-premise workload requirements to the cloud. The model also allows you to change compute, memory, and storage upon your workload needs. SQL Managed Instance is available in 2 tiers. We have the general purpose, which is designed for applications with typical performance and I/O latency requirements. Then we have the business critical tier, which is designed for applications with very low I/O latency requirements and minimal impact of underlying maintenance operations on the workload. Both service tiers, they guarantee a 99.99% availability and enables you to independently select storage and compute capacity. This brings us to the topic of describe the benefits and usage of the Azure Marketplace. Azure Marketplace. Now, this is an online catalog containing thousands of applications and services designed and optimized to run on the Microsoft Azure public cloud. Microsoft and its technology partners, they are responsible for developing the products and services you find on the Azure Marketplace. There are some clear benefits, of course, with the Marketplace. If you want to install a third-party product, such as a next-generation firewall, chances are there's already a ready-made product on the Marketplace which you can easily select and deploy into your subscription. In Chapter 6, we will describe the core solution and management tools in Azure. So, if we look at the core solutions and management tools in Azure, there's some things that we want to talk about. First of all, we're going to start with Internet of Things, IoT. Now, this is a collection of Microsoft managed cloud services that connect, monitor, and control billions of IoT assets. An IoT device is typically made up of a circuit board with sensors attached that use Wi-Fi to connect to the internet. So, for example, it can be a pressure sensor on a remote oil pump, temperature and humidity sensors in an air conditioning unit. It can be an accelerometer in an elevator. For example, also presence sensor in a room are examples of this. Azure IoT Central, now this is your app platform, one location that connects you with your devices, partner, app templates, and problem solvers. It's a web UI which lets you quickly connect devices, monitoring devices, conditions, create rules, and manage millions of devices and their data throughput through the whole life cycle. Using the IoT Central application, you go through the following steps. So first, you create an IoT Central application. You can use a generic application template to get you started. There are several of them available. Of course, depending on the industry that you want to use, such as retail, energy, government, healthcare. After creating the application, you then need to create and connect the devices. Every device connected to IoT Central uses a device template. Now, a device template is a blueprint which tells the device what it needs to do. For example, which telemetry data it should send. It could be temperature, humidity. It defines the device properties. For example, a valve is open or shut. It also does the commands that an operator can call on the device, such as remotely reboot it. You can customize the IoT Central application UI for the operators who are responsible for the day-to-day use of the application. So you can have custom dashboards with only data which is relevant to those specific operators. From here, it's also possible to manage the devices. Operators can perform tasks such as monitoring of the device. They can do some troubleshooting and provisioning of new devices. IoT Central can also be integrated in other business tools. You can export data, for example, to email, webhooks, Azure Monitor, custom applications, and many more. Now, Azure Sphere, talking about that one. Azure Sphere is all about protecting your IoT devices. The primary goal of this platform is to provide a high-value security at a low cost so that price-sensitive microcontroller-powered devices can safely and reliably connect to the internet. As network-connected toys, appliances, and other consumer devices become commonplace, security is of utmost importance, right? Not only must the device hardware itself be secured of its software and its cloud connections, but the cloud connections must also be secured. A security lapse anywhere in the change in the operating environments threatens the entire product and potentially anything or anyone nearby. So we're going to describe the benefits and usage of Azure Synapse Analytics, HD Insight, and Azure Databricks. Azure Synapse, that's an enterprise analytics service that accelerates time to insight across data warehouses and big data systems. Azure Synapse brings together the best of SQL technologies used in enterprise data warehousing. Spark technologies are used for big data. Data Explorer for log and time series analytics, pipelines for data integration, and ETL, ELT, and deep integration with other Azure services such as Power BI. Cosmos DB and Azure ML. Azure HD Insight is a cloud distribution of HADOP components. Azure HD Insight makes it easy, fast, and cost-effective to process massive amounts of data in a customized environment. You can use the most popular open-source frameworks such as HADOP, Spark, Hive, LLAP, Kafka, Storm, and many more. And with those frameworks, you can enable a broad range of scenarios, such as to extract, transform, and load ETL, data warehousing, machine learning, and IoT. Azure Databricks. Azure Databricks is a data analytics platform optimized for the Microsoft Azure Cloud Services platform. Azure Databricks, it offers 3 environments for developing data-intensive applications. We have the Databricks SQL, Databricks Data Science and Engineering, and Databricks Machine Learning, ML. Databricks SQL provides an easy-to-use platform for analytics. Who wants to run SQL queries on their data lake, create multiple visualization types to explore query results from different perspectives, and build and share dashboards. Databricks Data Science and Engineering, it provides an interactive workspace that enables collaboration between data engineers, data scientists, and machine learning engineers. Databricks Machine Learning, now that's an integrated end-to-end machine learning environment. It incorporates managed services for experiment tracking, model training, feature development and management, and feature and model serving. Now we're going to describe the benefits and usage of Azure Machine Learning, cognitive services, and Azure Bot Services. Machine learning, ML. Now this is the process of using mathematical models of data to help a computer learn without direct interaction. It's considered a subset of artificial intelligence, AI. Machine learning, it uses an algorithm to identify patterns within data and use those patterns to then create a data model that can make predictions. With increased data and experience, the result of the machine learning are more accurate, much like how businesses improve with more practice. The first step to machine learning is actually to collect the data. You need to first identify the data sources and make sure the information is usable. You train the model of data that you have captured. You then validate the model, and as a last step, you interpret the result that you have received. So in Azure, you create a workspace with a compute instance for machine learning. Cognitive services brings AI within reach of every developer and data scientist. With leading models, a variety of use cases can be unlocked. All it takes is an API call to embed the ability to see, hear, speak, search, understand, and accelerate advanced decision-making into your apps. You enable developers and data scientists of all skill levels to easily add AI capabilities to their applications. Then we have Azure Bot Services, which contains a framework for developers to author, test, and provision and manage conversational experiences. We're talking here about chatbots your enterprise can provide to its consumers. Now, for many companies, they serve now as the first level of support towards these customers. If the chatbot is not able to solve the query, it forwards it to a live agent who can then take it further. The whole framework around this is then available in Azure. We're going to have a look at the benefits of serverless computing solutions that include Azure Functions and Logic Apps. Now, Serverless computing solution in Azure, they consist of Azure Functions, which are serverless functions, Azure Logic Apps, serverless workflows. We have Azure Kubernetes Services, AKS, which is serverless Kubernetes. We have Azure API Gateway and Management, which is then serverless API Gateway. And we have the Azure App Services, which is serverless application environments. Now, the benefits of using serverless computing is, of course, you have no infrastructure management. You avoid administrative tasks and let you focus on the core business logic. You simply deploy your code and it runs with high availability. You have the dynamic scalability with that as well, meaning that the infrastructure, it scales up and down within seconds to match demand of the workload. You have faster time to market. It also reduces the operational dependencies on each development cycle. The dev teams are able to work more agile and deliver more functionality in less time. It's more efficient use of resources, of course, and it also helps organizations to reduce the TCO, total cost of ownership, and reallocate resources to focus more on innovation. We're going to just look at the benefits of Azure DevOps, GitHub, GitHub Actions, and Azure Dev Test Labs. Now, DevOps is a compound of development and operations bundled together. In the past, it was very common to have isolated teams for development and operations who did their own thing. DevOps brings these together, which actually allows for better collaboration and a more agile approach. Azure DevOps is a cloud environment which allows easy integration of DevOps for your organization. You can add Azure DevOps services with the tools of your own choice. So, whether you're a Java, Node, or .NET developer, or work in Jenkins, Ansible, or Puppet, Azure DevOps allows you to set up your end-to-end DevOps chain yourself. Within Azure DevOps, you have several services. You have Azure Boards, which allows you to plan, monitor, and discuss your team's activities. Azure Pipelines, now this is a CI/CD pipeline that works for virtually any activity platform and cloud, so you can carry out continuous deployment, development, and testing and implementation. We have Azure Repos, which gives you an unlimited number of Git repositories in the cloud. Azure Test Plans, where you manually and exploratory test programs to allow software to be both tested and released quickly. Then we have Azure Artifacts, which also allows you to easily share codes differently within teams and organization. In addition, you also have an extensive marketplace for Azure DevOps. This allows, of course, you to integrate things such as Slack, Jenkins, Docker, and other services. For GitHub, now at a high level, this is a website and cloud-based service that helps developers store and manage their code, as well as track and control changes to that. To understand exactly what GitHub is, you need to know two connected principles: version control and Git. Now, version control, it helps developers track and manage changes to a software project's code. As a software project grows, version control becomes essential. There can be many developers working on a project, and keeping track of all the versions is key. Now, Git, this is a distributed version control system, which means that for the entire code base and history is available on every developer's computer. So this allows for, of course, for easy branching and merging. GitHub is user-friendly throughout. So some people use GitHub to manage other types of projects. Even just if they want to write a book, they use GitHub. Additionally, anyone can sign up and host a public code repository completely for free, which makes GitHub especially popular with open source projects. As a company, GitHub makes money by selling hosted private code repositories, as well as other business-focused plans that makes it easier for organizations to manage team and their members and the security around it. GitHub Actions goes beyond DevOps and lets you run workflows when other events happen in your repository. So, for example, you can run a workflow to automatically add the appropriate labels whenever someone creates a new issue in your repository. Azure DevTest Lab, now that's a service that enables developers to efficiently self-manage virtual machines, VMs, and platform as a service services without waiting for any approvals. By using DevTest Labs, you can test the latest of your applications by doing some of the following tasks. Like, for example, you can quickly create Windows and Linux environments by using reusable templates and artifacts. You can also more easily integrate your deployment pipeline with the DevTest Labs to create an on-demand environment. You can scale up your load testing by creating multiple test agents and pre-prepared environments for training and demos. We're at Chapter 7, where we're going to describe the functionality and usage of Azure Portal, Azure PowerShell, Azure CLI, Cloud Shell, and the Azure mobile app. There are several ways to interface with Azure. We have, for example, the Azure Portal, which is accessible using the URL https://portal.azure.com. It provides a graphical interface to your Azure resources. You can easily navigate, get an overview, and see what's going on in your Azure environment. The benefit of the portal is its user-friendliness, especially if you only need to create or manage a limited amount of resources. This is the way to go. We have Azure PowerShell, which is a set of commandlets for managing Azure resources directly from the PowerShell command line. In order to use this, you only need to install the AZ module on your workstation. Now, why should you use Azure PowerShell, you may ask? Well, it's actually great to manage multiple resources in Azure. If you want to extract reports or modify multiple virtual machines, it's very easy to do this with Azure PowerShell. Azure CLI, now this is also a command line program that connects to Azure resources or Azure itself and executes administrative commands on them. It's more similar to Linux bash scripts, but feature-wise, it's almost identical to Azure PowerShell with some differences. The benefit of Azure CLI is that it's actually already pre-installed to use with Azure Cloud Shell. Which brings us to Azure Cloud Shell, which is a browser-based shell experience to manage and develop Azure resources. Cloud Shell offers a browser-accessible, pre-configured shell experience for managing these Azure resources without the overhead of installing, versioning, and maintaining a machine yourself. The only requirement for Azure Cloud Shell is a storage account in Azure. To help you manage Azure on the go, there's also a mobile app for Android and iOS. It has a basic interface for you to get a good overview of the Azure services, resources, and their health. You do get access to Azure Cloud Shell through this app, so in theory you can do a lot of management tasks on the go, provided you have an external keyboard, of course, because who would want to type advanced commands on a phone with a smart screen? Brings us to describe the functionality and usage of Azure Advisor. Now, Azure Advisor, this is a Microsoft Azure service that provides recommendations based on your deployed Azure services configuration. Azure Advisor, it shows a score per workload or resource you have deployed in Azure. Now, this score is based on how the resource adheres to Microsoft's best practices. You get a recommendation on what you can improve and how much that will help your score. This way, you get an idea what recommendations to prioritize based on how many points they give. So we're going to have a look and describe the functionality and usage of Azure Resource Manager templates, ARM templates. We have briefly mentioned the Azure Resource Manager templates, ARM templates, earlier. You can automate deployments and use the practice of infrastructure as code. In code, you actually define the infrastructure that needs to be deployed. The infrastructure code becomes then part of your project. Just like application code, you actually store the infrastructure code in a repository and you version it. So anyone of your team can then run the code and deploy it in similar environments. To implement infrastructure as code for your Azure solutions, you use Azure Resource Management templates, ARM templates. These templates is just actually a JavaScript object notation JSON file that defines the infrastructure and configuration for your project. The templates uses a declarative syntax which lets you state what you intend to deploy without having to write a sequence of programming commands to create them. In the template itself, you actually specify the resources you want to deploy and the properties for those different resources. This brings us to the functionality of Azure Monitor. Azure Monitor, it helps you to maximize the availability and performance of your applications and services. It delivers a comprehensive solution for collecting, analyzing, and acting on telemetry from your cloud and on-premise environment. This information, it helps you to understand how your applications are performing and proactively identifying issues affecting them and the resources they depend on. The following diagram you can see there gives a high-level view of Azure Monitoring. At the center of the diagram are the data stores for metrics and logs, which are the two fundamental types of data used by Azure Monitor. On the left, there are the sources of monitoring, or data that populate these data sources. On the right, there are the different functions that Azure Monitor performs with the collected data. These include activities such as analyzing, alerting, and streaming to external systems. And now we're going to look at the usage or service of Azure Service Health. Azure Service Health provides a personalized view of the health of the Azure services and regions you're using. This is the best place to look for service impacting communications about outages, planned maintenance activities, and other health advisories, because the authenticated Service Health experience knows which services and resources you currently use. So the best way to use Service Health is to set up a Service Health notification. And in order to do that, you need to set up your preferred communication channel, if that's email, phone, so you can get an idea when there's a planned maintenance or other outages affecting Azure services and regions that you use. Chapter 8 describes the general security and network security features. We're also going to describe the basic features of Microsoft Defender for Cloud, including policy, compliance, security alerts, secure score, and resource hygiene. Cloud Security Posture Management, CSPM. Now, this is a market segment for IT security tools that are designed to identify misconfiguration issues and compliance risks in the cloud. An important purpose of CSPM programming is to continuously monitor cloud infrastructure for gaps in security policy enforcement. Cloud Workload Protection, CWP. This is the process of continuously monitoring for and removing threats from the cloud workloads and containers. Microsoft Defender for Cloud. This is a solution for cloud security posture management, CSPM, and for cloud workload protection, CWP. Idea is that it finds weak spot across your cloud configuration, helps you strengthen the overall security posture of your environment, and can protect workloads across multi-cloud and hybrid environments. Now, there are three main areas to the Microsoft Defender for Cloud. We have continuous assessment, which is understand your current security posture. We have a secure score, which is a single score so that you can tell at a glance your current security situation. The higher the score, the lower the identified risk level. Secure, which is to harden all connected resources and services. Security recommendations, for example, customized and prioritized hardening tasks to improve your posture. You implement a recommendation by following the detailed remediation steps provided in the recommendation. For many recommendations, Defender for Cloud, it offers you a fix button, which you can click on for automated implementation. You have Defend, which is detect and resolve threats to those resources and security alerts with the enhanced security features enabled. Defender for Clouds detects threats to your resources and workloads. These alerts appear in the Azure Portal, and Defender for Cloud, it can also send them to email to the relevant personnel in your organization. Alerts, they can also be streamed to SIEM, SOAR, or an IT Service Management Solution, ITMS, as required. For Cloud Security Posture Management, CSPM, Microsoft Defender for Cloud does the following. It generates a secure score for your subscriptions based on an assessment of your current connected resources compared with the guidance in the Azure Security Benchmark. You can use this score to understand your security posture and the compliance dashboard to review your compliance with the built-in benchmark. When you've enabled the enhanced security features, you can then customize the standards to assess your compliance, and you can add other regulations such as NIST and Azure SIS or organization-specific security requirements. Provide hardening recommendation based on any identified security misconfiguration and weaknesses. Use this security recommendation to strengthen the security posture of your organization's Azure, hybrid, or multi-cloud resources. For Cloud Workload Protection, CWP, Defender for Cloud, it offers security alerts that are powered by Microsoft Threat Intelligence. It also includes a range of advanced intelligent protections for your workloads. Defender for Cloud, it helps you to detect threats across Azure PaaS, Platform as a Service, services such as Azure App Service, Azure SQL, storage accounts, and more data services. Networks such as identifying brute force attacks and hardening attacks to your Azure resources. In addition to defending your Azure environment, you can add Defender for Cloud capabilities to your hybrid cloud environment to protect your non-Azure servers using Azure Arc. We're going to describe the functionality and usage of Key Vault. Azure Key Vault. Now, this is a cloud service for securely storing and accessing secrets. A secret is anything that you want to tightly control access to, such as API keys, passwords, certificates, or cryptographic keys. Anybody with an Azure subscription can create and use Key Vaults. Although Key Vault benefits mostly developers and security administrators, it can actually be implemented and managed by an organization's administrator who manages other Azure services as well. Azure Key Vault enforces TLS, Transport Layer Security Protocol, to protect data when it's traveling between Azure Key Vault and clients. Clients, they negotiate a TLS connection with Azure Key Vault. Now, TLS, it provides strong authentication, message privacy, and integrity. Means enabling detection of message tampering, interception, and forgery. It also does interoperability. It has a lot of flexibility and ease of use for deployment. Access to a Key Vault is controlled through two interfaces, the management plane and the data plane. The management plane, now that's where you manage Key Vault itself. Operations in this plane include creating and deleting Key Vaults, retrieving Key Vault properties, and of course updating access policies. The data plane, now that's where you work with the data stored in a key vault. You can add, delete, and modify keys, secrets, and certificates. Both of these planes, they use Azure Active Directory, Azure AD for authentication. For authorization, the management plane uses Azure Role-Based Access, RBAC, and the data plane uses a Key Vault access policy and or Azure RBAC for Key Vault data plane operations. To access a Key Vault in either plane, all callers, users or application must have proper authentication and authorization. Authentication that establishes the identity of the caller. Authorization determines which operations the caller can execute. Authentication with Key Vault works in conjunction with Azure Active Directory, Azure AD, which is then responsible for authenticating the identity of any given security principal, such as a user. We're going to describe and have a look at the functionality of Microsoft Sentinel. Security Information and Event Management SIEM software gives enterprises security professionals both insight into a track record of activities within their IT environment. SIEM software, it collects and aggregates log data generated throughout the organization's technology infrastructure. It does this from host systems and applications to network and security devices such as firewall and antivirus filters. The software then identifies and categorizes incidents and events, as well as analyzes them. The software delivers on two main objectives, which are to, first, provide reports on security-related incidents and events, such as successful and failed logins, malware activity and other possible malicious activities, and send alerts if analysis show that an activity runs against predetermined rule set and thus indicates a potential security threat. Microsoft Sentinel is scalable, cloud-native security information and event management system, SIEM. Security Orchestration, Automation and Response, SOAR, it's also part of this solution. So Microsoft Sentinel is your bird's eye view across the enterprise, alleviating the stress of an increasingly sophisticated attack, increasing volume of alerts, and long resolution time frames. Collect data at cloud scale across all user devices, applications, and infrastructure, both on-premise and in multiple clouds. Also, it detects previously undetected threats and minimizes false positive for Microsoft Analytics and unparalleled threat intelligence. It investigates threats with artificial intelligence like Terminator and hunt for suspicious activities at scale, tapping into years of security work at Microsoft. It responds rapidly to incidents with built-in orchestration and automation of common tasks. We're going to describe the functionality and usage of Azure Dedicated Host. Now, Azure Dedicated Host is a service that provides physical servers able to host one or more virtual machines dedicated to one Azure subscription. It's basically dedicated hypervisor hosts that are used only by your organization. Reserving the entire host provides some of the following benefits. You have, for example, hardware isolation at the physical server level. No other virtual machines will be placed on your hosts. Their dedicated hosts are deployed in the same data center and share the same network and underlying storage infrastructure as other non-isolated hosts. You have more control over maintenance events initiated by the Azure platform. While the majority of maintenance events, they have little to no impact on your virtual machines, there are some sensitive workloads where each second of a pause can have an impact. With dedicated hosts, you can opt in to a maintenance window to reduce the impact of your service. This comes to describing the Azure network security, the concept of defense in depth. So let's have a look at that. Defense in depth. Now, this is a security risk management approach that defines multiple layers of security controls in an IT environment, so that if a security attack is not caught by one layer, first layer, it will probably be caught by next. The multiple layers increases the overall security score of an environment and reduce the probability of a security breach by a huge margin. Cloud security is a shared responsibility. Each of the security layers is the responsibility of either the cloud provider or the customer. In the case of Azure, below you can see, or in the screenshot, a snapshot of the security layer, where the physical security with Microsoft owns the Azure data centers and manages the physical security at all the locations. Only authorized personnel have access to the different areas of the data centers. Identity and access. All Azure resources are governed and controlled through Azure Active Directory, which is the control and central identity plane. Further, you can control access to your Azure resources using RBAC, role-based access control. Users can be granted higher privileges just in time using Azure Privileged Identity Management, PIM. By default, Azure enables basic distributed denial of service protection, DDoS protection, which comes with always-on traffic monitoring and real-time mitigation of common network-level attacks. The standard tier of DDoS protection, it provides additional capabilities to protect against, for example, volumetric attacks, protocol attacks, and application attacks. Network, you can also filter network traffic to and from Azure resources in a virtual network. You do this through network security groups, which contains security rules allowing or denying traffic. Under Azure Security Center standard pricing tier, you can lock down inbound traffic to your Azure VMs with just-in-time VM access, for example, RDP SSH. Compute. Azure Security Center provides protection against threats by its ability to process signals and detect security threats like RDP brute force attacks and SQL injections. The Security Center, it also gives a secure score based on the assessment of the security posture of your environment. Application, for example, application gateways and web application firewall provides a centralized protection of your web applications from common exploits and vulnerabilities. Azure Front Door, now this is another service that allows you to author custom web application and web application firewall rules for access control to protect your HTTPS workload from exploitation based on client IP addresses, country code, and HTTP parameters. A managed identity from Azure Active Directory, AAD, allows your app to easily access other Azure Active Directory protected resources, such as Azure Key Vault. The identity is managed by the Azure platform, and it does not require you to provision or rotate any secret. Also, you can enable SSL on your app services. Data. Data is encrypted at rest for both structured and unstructured data. You can further control access to the data using authentication mechanisms. We're going to have a look at the functionality and usage of network security groups, NSGs. You can use an Azure Network Security Group to filter network traffic to and from an Azure resource in an Azure virtual network. You can configure network security groups on the following places. You have them on vNets, vNet subnets, and NICs of a virtual machine. Now, Microsoft Best Practices recommends to apply NSGs on subnets in Azure instead of NICs. NSGs, they consist of the following properties. You have a source or destination. This is any IP address or a full CIDR block. Service tag or an application security group, ASG. You have a service, which is a predefined set of ports based on protocol. Then we have port range. Here you can specify an individual range of ports. Protocol, TCP, UDP, ICMP, ESP, AH, or any. Action, allow or deny. Priority, this is a number in which rules are processed in priority order. Lower numbers are processed before higher numbers. Once traffic matches a rule, it stops. We also have a name, which is actually a unique name within a security group. Service tag, a service tag, it represents a group of IP address prefixes from a given Azure service. It helps to minimize the complexity and frequent updates on network security rules. Application security groups, ASG. Now, application security groups, they enable you to configure network security as a natural extension of an application structure, allowing you to group virtual machines and define network security policies based on those groups. You can reuse your security policies at scale without manual maintenance of explicit IP addresses. We're going to have a look at the functionality and usage of Azure Firewall. Azure Firewall, now this is a cloud-native and intelligent network firewall security service that provides the best of breed of threat protection for your cloud workloads running in Azure. It's a fully stateful firewall as a service with built-in high availability and unrestricted cloud scalability. It provides both east and west, north and south traffic inspection. There are two SKUs for Azure Firewall. You have the standard and you have the premium SKU. Now, Azure Firewall Standard, it provides layer 3 to layer 7 filtering and threat intelligence feeds directly from Microsoft Cybersecurity. Threat intelligence-based filtering can alert and deny traffic from, for example, 2 known malicious IP addresses and domains which are updated in real time to protect against new and emerging attacks. Azure Firewall Premium provides advanced capabilities, include signature-based IDPS to allow rapid detection of attacks by actually looking for specific patterns. These patterns can include byte sequences in network traffic or known malicious instruction sequences used by malware. There are more than 58,000 signatures in over 50 categories which are updated in real time to protect against new and emerging exploits. The exploit category includes malware, phishing, coin mining, and Trojan attacks. We're going to describe and have a look at the functionality and usage of Azure DDoS protection. Distributed denial of service, DDoS attacks, are some of the largest availability and security concerns facing customers that are moving their applications to the cloud. A DDoS attack, it actually attempts to exhaust an application's resources, making the application vulnerable or unavailable to legitimate users. DDoS attacks can be targeted to any endpoint that is publicly reachable through the internet. Every property in Azure is protected by Azure's infrastructure DDoS basic protection at no additional cost. This scale and capacity of the globally deployed Azure network provides a defense against common network layer attacks through an always-on traffic monitoring and real-time mitigation. DDoS Protection Basic requires no user configuration or application changes. DDoS Protection Basic helps all Azure services, including PaaS services like Azure DNS. Azure DDoS Protection Standard. Now this, combined with the application design best practices, provides enhanced DDoS mitigation features to defend against DDoS attacks. It is automatically tuned to help protect your specific Azure resources in a virtual network. Protection is simple to enable on any new or existing virtual network, and it requires no application or resource changes. It has several advantages over the basic service, including logging, alerting, and telemetry data. Chapter 9, where we're going to describe identity, governance, privacy, and compliance features in Azure. We will also describe the core identity services. So, the differences between authentication and authorization, right? Now that we're getting into identity and access management, we will first talk about the differences between authorization and authentication. Authentication, you can think of it as the process of verifying who someone is. In Azure, this can be while logging onto the Azure Portal and providing a two-factor authentication. You then have, in some sense, proved who you actually are. Authorization, it's the process of verifying what you should have access to. Should you manage the entire Azure subscription, or should you only manage a virtual machine there? So we're going to define the Azure Active Directory, which is actually another identity tool. So do not confuse this with your local Windows Active Directory domain services, because it's not a full-fledged Active Directory domain services as we're used to. Instead, it's just an identity and access management service for the Azure cloud. It's mainly used to authenticate towards Azure resources. How does it do that? Well, you first need to have an identity in your Azure Active Directory. Now, this is mostly done by syncing users that are located on your premise AD to Azure Active Directory. This means that the users you have on premise can automatically authenticate in Azure with their existing ID and password. It's not a hard requirement to actually sync these identities from on-premise, as you can also manually create identities in Azure Active Directory. Now we're going to have a look at the functionality and usage of Azure Active Directory. So let's have a look at the features available for Azure Active Directory here. And if we look at the feature, we have, for example, application management, where you can manage your cloud and on-premise applications using application proxy, single sign-on, the MyApps portal, also known as the Access Panel, and software as a service, SaaS applications. You have authentication, where you manage Azure Active Directory, the self-serving password resets. You have multi-factor authentication. You have a custom banned password list and smart lookup. You have business to business, where you manage your guest users and external partners while maintaining control over your own corporate data. Enterprise users, you manage license assignment, access to apps, and set up delegates using groups and administrator roles. Hybrid identity, use Azure Active Directory Connect and Connect Health to provide a single user identity for authentication and authorization to all resources regardless of location, cloud or on-premise. We have identity governance, which is where you can manage your organization's identity through employee, business partner, vendor, service, and app access controls. You can also perform access reviews. Identity protection, where you detect potential vulnerabilities affecting your organizational identities. You configure policies to respond to suspicious activities and then take appropriate action to resolve them. Managed identities for Azure resources. It provides your Azure services with an automatically managed identity in Azure AD that can authenticate to any Azure Active Directory supported authentication service, including Key Vault. We have PIM, Privileged Identity Access Management. Manage, control, and monitor access within your organization. This feature includes access to resources in Azure Active Directory and Azure itself, and other Microsoft Online services like Microsoft 365 or Intune. Reports and monitoring gain insight into the security and usage pattern in your environment. Brings us into describing the functionality and usage of conditional access, multi-factor authentication, MFA, and single sign-on, SSO. Now, conditional access policy, CAP, that allows you to set requirements in order for a user to access a resource. For example, a payroll manager wants to access a payroll application. Then they are required to use multi-factor authentication. The first step in conditional access policies are something called signals. These are the conditions that are evaluated, such as user or group membership. So depending on which group the user is a member of, we then have IP location information. You have a set of trusted IP ranges that can be added here. The administrator can also specify countries or geographic locations based on these IP addresses. We have device users, and that's users with a specific device or platform. And we have application users attempting to access a specific application, which can then trigger a conditional access policy. So based on this signal, a decision has to be taken. What do we do? Do we block access? Do we grant access but require MFA? Moving on further, we then can do a deep dive into MFA, multi-factor authentication, which is a process where a user is prompted during the sign-in process for an additional form of identification. Now, if you only use a password to authenticate a user, it leaves an insecure vector for the attack. If the password is weak or has been exposed elsewhere, is it really the user signing in with the username and password, or is it an attacker or somebody else? Azure AD multi-factor authentication, it works by requiring 2 or more of the following authentication methods. You need to have something you know, which is then typically a password. Then you need to have something you have, such as a trusted device that is not easily duplicated, like a phone or a hardware key. Something you are, which is biometrics like a fingerprint or a face scan. When a user signs into an application or service and receives an MFA prompt, they can then choose from one of their registered forms of additional verification. Users can access My Profile to edit or add verification methods. The following additional form of verification can be used with Azure AD MFA. So for that, we have Microsoft Authenticator app. We have an OAT hardware token, which is in preview. We have an OAT software token. You can receive an SMS or a voice call. Azure Active Directory Seamless Single Sign-On, Azure AD Seamless SSO. Now this automatically signs users in when they are on their corporate devices connected to your corporate network. When enabled, users they don't need to type in their password to sign into Azure AD, which is a great feature. Seamless sign-on, it can be combined with either the password hash synchronization or pass-through authentication sign-in methods. So when you sync your identities from on-premise to Azure, you have the option to do either password hash synchronization or pass-through authentication. Password hash synchronization, PHS, is actually a hash of your password stored in Azure Active Directory. So Azure Active Directory can then use this hash to validate your password. Pass-through authentication means that Azure Active Directory lets your on-premise perform the authentication. There is no hash of your password stored in the cloud. For devices, Azure AD join devices, it's important to mention that devices can be joined to Azure AD. There are about a couple of different ways a device can be joined. You have domain joined devices, hybrid joined devices, you have Azure AD joined devices, and you also have Azure AD registered devices. Now, what you choose depends on factors such as who owns the data, who gets to manage the device, what features do the application need, where is authentication going to happen. Now, domain join, this is the traditional devices connected to on-premise AD. You log in with your corporate user ID. Authentication is only via on-premise AD, and it's managed using group policies. Hybrid Azure AD joined is actually for corporate owned and managed devices. They're authenticating using corporate user ID that exists in local AD, and Azure AD authentication can be done both on-premise and in Azure AD. They're managed using group policies. The ID is for corporate-owned laptops, for example. It's ideal for that. Then we have Azure AD joined devices, which is for corporate-owned and managed devices. It's authenticated using a corporate ID that exists on Azure AD. Authentication is through Azure AD, and you can have actually access to on-premise resources as well. Management is using MDM tools, and it's ideal for corporate-owned laptops or mobile devices in a cloud or cloud-centric environment. We have Azure AD registered devices, which is for personally owned but corporate-enabled devices, like bring your own device. Authentication to the devices is with the local ID or personal cloud ID, such as an Outlook.com address. You can authenticate to corporate resources using your user ID in Azure AD. Management can there be done with the MDM tools, and it's ideal for personally owned laptops or mobile devices. So we're going to describe the Azure governance features. We're going to look at the functionality and usage of role-based access control, RBAC. We're going to look at that for cloud management resources. And this is a critical function for any organization that is using the cloud. Azure Role-Based Access Control, RBAC, it helps you manage who has access to the Azure resources, what they can do with those resources, and what areas they have access to. Here are some of the examples what you can do with Azure RBAC. We can allow one user to, for example, manage multiple virtual machines in a subscription, and another user to manage the virtual networks. We can allow a DBA group to manage SQL databases in a subscription. We can allow a user to manage all the resources in a resource group, such as virtual machines, websites, and subnets. We can allow an application to access all resources in a resource group as well. Now, the way you control access to resources using Azure RBAC is to assign Azure role. Now, Azure roles, this is a key concept to understand. It's how permissions are enforced. A role assignment consists of three elements: security principle, role definition, and scope. Security principle, now that's an object that represents a user, group, service principal, or a managed identity. And this is then requesting access to an Azure resource. You can assign roles to any of these security principles. And a role contains a role definition, which is a collection of permissions. It's typically just called a role. So a role definition lists all the actions that can be performed, such as read, write, and delete. Roles can be high level, like owner, or very specific, like virtual machine reader. Scope, now that is the set of resources that the access applies to. This can be on management groups, subscriptions, resource groups, or even individual resources itself. We're going to have a look at the functionality and usage of resource logs. As an administrator, you can lock a subscription, resource group, or resource to prevent other users in your organization from accidentally deleting or modifying critical resources. This log overrides any permission the user might have. These are called resource logs within Azure. You can set the log level to, for example, cannot delete or read only in the portal. And in the portal, the logs are called delete and read only respectively. Cannot delete means authorized users can still read and modify a resource, but they cannot delete the resource. Read only means authorized users can read a resource, but they cannot delete or update the resource. Applying this log is similar to restricting all authorized users to the permissions granted by the reader rule. When you apply a log at the parent scope, all resources within that scope inherit the same log. Even resources you add later, they inherit that log from the parent. So the most restricted log in the inheritance change, that's the one that takes precedence. Resource log in practice are usually applied to business critical infrastructure in Azure. For example, all shared networking components used by an organization. We're going to have a look at the functionality and usage of tags. Tags. You can apply tags to your Azure resources, resource groups, and subscriptions to logically organize them. Each tag consists of a name and a value pair. For example, you can apply the name environment and the value production to all resources in production. Now, why should you use tags? Well, one key thing is financial management. You can, for example, force all virtual machines that are created for a specific project to have a certain tag. Afterwards, it's very easy to pull out reports based on a project tag and get an overview of only those resources. In practice, it's used to divide the billing up further within the organization. Now we come to the functionality and usage of Azure Policy. Azure Policy, now that's a service in Azure which allows you to create policies which enforce and control the properties of a resource. When these policies are used, they enforce different rules and effects over your resources, so those resources, they stay compliant within your IT governance standards. For example, you can set up a policy to require a certain tag to be specified. A policy can be set to only allow virtual machines to be created in a certain region. We're going to describe the functionality and usage of Azure Blueprints. Azure Blueprints. Now, this is a way to sketch out the infrastructure and then deploy it in a consistent manner. Blueprints, they contain basically everything to set up an infrastructure in Azure. You can create a blueprint and in there add, for example, resource groups, policies, role assignments, and specify which ARM templates to be built. By deploying a blueprint, you then not only have the infrastructure, but all the access permissions and policies in place for the entire infrastructure. We're going to describe the Cloud Adoption Framework for Azure. Now, the Cloud Adoption Framework, CAF, is a collection of documentation, implementation guidance, best practices, and tools that are proven guidance from Microsoft designed to accelerate your cloud adoption journey. If you want to bring your organization into Azure, this is a great framework to follow. It provides guidance on both the business strategy as well as on a technical level. There are several pillars in the Cloud Adoption Framework. We have defined strategy, where we have business outcomes and justification. We have plan, where we inventorize and plan the move. Ready, where we prepare the setup guides. We create the first landing zone, MVP. We have adopt, migrate, and innovate. We have govern, where we ensure methodologies and benchmarks have been followed. We have manage, where we ensure business commitments are continuously met. We're now at chapter 10, which is to do about privacy. So we're going to describe the privacy and compliance resources. And we're also going to describe the Microsoft core tenets of security, privacy, and compliance. The Microsoft Trusted Cloud was actually built on the foundational principles of security, privacy, compliance, and transparency. Security, it has to do with keeping customer data secure. Privacy, it's all about giving customers ownership and control of their own data. Compliance, it has to do with conforming to global security standards. Transparency, meaning that Microsoft gives a broad visibility into the Azure processes and best practices. So we're going to have a look at the Microsoft Privacy Statement, Online Service Terms, OST, and the Data Protection Amendment, DPA. The Microsoft Privacy Statement. Now, this is a document which goes into detail on how Microsoft processes data and for what purpose. It describes, for example, things like the personal data which they collect, how they use this data. For example, they state that they use the data to operate their business and make improvements in the Azure platform. How you access and control your personal data is also in this document. And there are many more details on how they handle privacy. What's the online service term, OST, and what's in it? The online service term, OST, now this is a legal agreement between Microsoft and the customer. This document, the OST, details the obligation by both parties with respect to the processing and security of customer data and personal data. The OST applies specifically to Microsoft's online services that you license through a subscription, including Azure, Dynamics 365, Office 365, and exciting Bing Maps. The Microsoft Products and Services Data Protection Addendum, DPA, this is a document which describes in detail the data processing and security terms used by Microsoft when you subscribe to their services. These terms, they include, for example, compliance with laws, disclosure of processed data, data security, which includes security practices and policies, data encryption, data access, customer responsibilities, and compliance with auditing. You have also data transfer, retention, and deletion. We're going to describe the purpose of the Trust Center. The Trust Center, this is an important part of the Microsoft Trusted Cloud initiative, and it provides support and resources for the legal and compliance community. The Trust Center also provides in-depth information about security, privacy, compliance offerings, policies, features, and practices across the Microsoft Cloud products. There are additional resources for each topics, links to security, privacy, and compliance blogs, and upcoming events. So we're going to have a look at the purpose of the Azure Compliance Documentation. Now, the Azure Compliance Documentation is where you find a list of all regulatory compliance offerings by Microsoft. Keep in mind that as the owner of the business, you are responsible to ensure that the Azure clouds meet your compliance requirements. So if you visit the website, you find the links and documentation to compliance in Azure. This brings us to the purpose of the Azure Sovereign Regions, Azure Government Cloud Services, and Azure China Cloud Services. Microsoft, they make the following Azure cloud environments available. We have Azure is available globally. It is sometimes referred to as Azure Commercial Cloud, Azure Public, or Azure Global. Now, Azure China, this is available through a unique partnership between Microsoft and 21 vNets, one of the country's largest internet providers. Azure Government is available from 5 regions in the United States to the US government agencies and their partners. 2 regions, US Department of Defense Central and US DoD East, are reserved for exclusive use by the US Department of Defense. Azure Government Secret is available from 3 regions exclusively for the needs of the US government, and it's designed to accommodate classified secret workloads and native connectivity to classified networks. Azure Government Top Secret serves the national security mission and empowers leaders across the intelligence community, IC, Department of Defense, DoD, and federal civilian agencies to process national security workload classified at the US top secret level. We are now at section 11. Now we're going to describe the methods for planning and managing costs. We're going to identify factors that can affect costs, resource types, services, location, ingress and egress traffic. It may sound very comfortable that you only pay for what you consume in the cloud. However, you still need to keep in mind that everything that you do there comes at a cost. So I'll give you a rundown of some examples. Virtual machine pricing, they're based on sizing, CPU, memory, and storage. Just like most services in Azure, you have a huge amount of options to choose from. Costing has to be done very carefully, because pricing virtual machine, it may sound simple, but you also have to factor into additional costs such as monitoring, backup, data transfer, other activities related to the virtual machine. Regarding data costs, it's always stated and said that ingress traffic to Azure is free. Now, that is not entirely true. Ingress traffic to Azure is only free to the first virtual network. If traffic needs to pass through multiple networks in Azure to reach its destination, you will pay for this additional traffic. Egress traffic, which is actual traffic outgoing from Azure to the internet or your on-premise environment, is being charged. We're going to identify factors and check what we can do to reduce the cost, such as reserved instances, reserved capacity, hybrid user benefits, spot pricing. Now, pricing a solution in Azure has to be done very carefully, as I've stated, as there are multiple ways to save costs. So here are a few. Used reserved instances, RI, for virtual machines. You can reserve your virtual machines for 1 or 3 years and receive a huge discount. Azure spot pricing, now that allows you to use unused virtual machine capacity in Azure at a very cheap price. You basically tell Microsoft that, hey, I want to use a certain virtual machine spot instance, and it will be allocated to you when there's capacity available. It's highly discounted and used for workloads that are not time critical. For Azure SQL databases and Azure Cosmos DB, you can explore the usage of reserved capacity as well. This is also on a 1 or 3 year commitment. We have Azure Hybrid Benefit, which is a licensing benefit that helps you significantly reduce the cost of running your workloads in the cloud. It works by letting you use your on-premise software assurance enabled Windows Server, SQL Server licenses, and Red Hat SUSE Linux subscriptions in Azure. This brings us to describing the functionality and usage of the pricing calculator and the TCO, total cost of ownership calculator. To help you through the costing, you have basically 2 tools at your disposal from Microsoft. You have the Azure pricing calculator and the total cost of ownership calculator, the TCO calculator. Now, both of them are publicly available on the internet. On the Microsoft site, you will find them. The Azure pricing calculator is there to give you an exact pricing on the monthly cost, how much the infrastructure will be charged. You can add all the billable items available in Azure into this calculator, and it will give you a price for the service. The TCO calculator, now this is there to give you an indication how much you would save moving your workload to Azure. It's a web wizard where you define the workload you want to move, such as servers, databases, and the amount of storage. It will provide you with a graph of how much cheaper it is to have your infrastructure in the Azure cloud. So we're going to look at the functionality and usage of the Azure cost management. It's incredibly nice to have tools with hundreds of parameters which can then calculate the cost in Azure. The problem is that it's just theory crafting, and it may not reflect the actual situation. Now, this is where the Azure cost management comes into play. It's a free tool built into the Azure Portal, and it provides you with information on the cost for your cloud infrastructure. You can view the current cost, historical cost, and the projected cost. It's a very useful tool where you can also configure alerts to be triggered when the cost becomes too high. We're going to look at Azure Service Level Agreement, SLAs, and service life cycles. So we're going to describe the purpose of the Azure Service Level Agreement, SLAs. Now, the service level agreement, SLAs in Azure, now they describe the Microsoft commitments and uptime and connectivity for every service provided in Azure. May it be, for example, virtual machines, firewall, and more. There's always an SLA by Microsoft. Failure by Microsoft to meet this SLA will provide you and your organization with something called service credits. So it's very important when you design your Azure infrastructure to do it in accordance with the required SLA. We can now identify actions that can impact an SLA, which, for example, availability zones, those are important. So there are a lot of options you can choose from with regards to SLA. As with everything, it always comes with a price. Higher SLA, higher price. If you want to keep your infrastructure locked in a specific region, you can, for example, spread it out across different availability zones. The next step out of availability zone is use an extra region as redundancy, which of course will also have an influence on the SLA you will get. We're going to describe the service lifecycle in Azure, public preview and general availability. Microsoft, they basically handle 3 programs when it comes to a service lifecycle in Azure. This way they get to test and evaluate new features before they are released to everyone. First, there is a private preview, which is where Microsoft invites a few customers to take part in early access to a new concept and feature they want to have in Azure. After this, the feature reaches something that's called public preview, which allows any eligible customer to actually test out the feature. For most features in public preview, you need to opt in to use them using the Azure Portal. And the last step is making sure this feature goes into GA, which stands for General Available. The feature is then opened for any eligible customer with full support from Microsoft. That was all which was required for the Azure Fundamental exam. You may want to revisit certain chapters if you need to have a refresh. If you found the course useful, hit the like and subscribe button at the bottom of the video. Good luck on taking your exam and stay tuned to the Patrick's Tech Lightning channel for more interesting content. Until next time, take care.